Acceleration has to be found out in both cases, that is OA case and AB case. OA case. Final velocity minus initial velocity divided by time.
0.2 meter per second square.
Can you do the second part now? B, that is.
Minus 0.4 meter per second square.
Anybody has problem with the second part or any questions? Let me know. So in that case, I will move on to the next one. All right. This one is for you to try out, and I want the answer in meter per second square.
So minus 1.11 meter per second square.
I will have to check that. It is correct. Any questions? Let me know. Yes, go ahead.
Sir, can we say that body has a retardation of 1.11 meter per second square?
Oh yes. Yes.
So 0.0185 meter per second square.
Can you repeat?
Sir, 0.0185 meter per second square.
What are you getting without division? Just in
So
fraction?
20 by 18 meters per second square.
You are getting 20 by 18.
100 by 54 meters per second square.
100 by 54 is certainly different from 20 by 18. I will have to check.
Sir, 11.11 by 600.
Ten minutes. So that has to be converted to seconds. See if you are getting the same answer. Still, if you are getting something else, then let me know. The next thing is graphical representation of motion. Let's first talk about distance-time graph. Distance-time graph. If speed is fixed, then equal distance is traveled in equal interval. If speed is fixed. So you find that distance-time graph is a straight line. This can be easily verified by actual plotting. But this is so only if speed is fixed. And how does one find speed from this graph? Take any two time points corresponding to those time points. You will get distance points, and speed would be this. So in t2 minus t1 time, Distance traveled is S2 minus S1. And because speed is constant, I can take any 2 points of my liking. So such cases are easy cases of constant speed. But in real life, it may not be like this. It can be very complicated actually. But one commonly encountered case is of constant acceleration. When acceleration is constant, and in that case, distance-time graph can look somewhat like parabola, half parabola type. Distance versus time. But you cannot talk about speed in this manner because it is not a constant speed. But yes, you can talk about average speed. You can talk about average speed. But it will be average. Here it is the same everywhere. So it is a true speed also. Instantaneous speed is generally called the true speed. Speed at that very moment. So when we generally say speed, we mean instantaneous speed. So in case of constant speed case, speed at every moment is instantaneous speed, and that same everywhere. Here we can talk about average speed. When we say speed is changing, it doesn't mean it has to be only this type of graph only. There can be very complicated situations. In real life, it could be very complicated. So when I say half parabola type, it is a particular case of constant acceleration. This is a case of zero acceleration. Acceleration can be zero, acceleration can be constant, but acceleration can be variable also. And in real life, generally it is variable. So you know, when you sit inside a school bus, what does driver do? Sometimes accelerates rapidly, sometimes slows down, sometimes just bus is standing. All those things happen and they keep on changing. So neither is acceleration zero all the time, nor is it fixed all the time. It is changing all the time. That's most complicated case that we encounter in real life situation. But we won't have to get into that in our scope of discussion. We will be primarily focusing on constant speed or zero acceleration case or constant acceleration case. Linear always means, linear or straight line type of behavior always means it is constant speed case. And non-straight line, which also is called non-linear, like you are learning cubic polynomial or quadratic polynomial, these are all non-linear. Polynomial with one power, that is linear. Highest power is 1, degree is 1. That is linear polynomial. So non-linear behavior will be there in real life situation, and that too fluctuating. Non-linear fluctuating behavior. What's going on? Now the image that you are seeing on the board, it's a distance versus time graph. It is drawn for 3 objects A, B and C. You can see the markings A, B and C. Now the first question is, which of these 3 is traveling the fastest? Which of the 3 is traveling the fastest? So what's your answer?
Sir, I'm not able to see the distance time graph on my board.
Yes, it's possible because I can see some red orange thing in front of your name. So just wait. The first question is, which of the 3 is traveling the fastest?
Sir, B.
Sir, B.
B. You can see that these are all straight lines, so it's a case of constant speed for everybody, right? So how do you know if who is fastest? You can take any 2 points. You can take any 2 points for time and see how much distances each one of them is traveling. How much distance each one of them is traveling in the same time. So in case somebody requires more explanation for this part, which of the 3 is traveling the fastest part, then let me know. Or should I assume that nobody has problem with that? The answer is B. Okay. So B is fastest. Then we go to the next question. Are all 3 ever at the same point on the road? Are all 3 ever at the same point on the road? Assume it's a straight line motion in one direction. Will they ever meet? That's the question.
Sir, no, they won't meet.
They won't meet is the correct answer. You can see that, look at the pointer, that here B and C are meeting here. You can also see that A and B are meeting here. And C and A are also meeting. But all 3 at the same point, no, it never happens. Any questions regarding this question? If you have, then let me know. Then another question is, how far has C traveled when B passes A? When B passes A, how far has C traveled?
Sir, 8 kilometers.
8 kilometers. Are you sure? Anybody else?
Sir, 11.5 kilometers or 11 kilometers.
11.5. Let's see.
So it's 9 kilometers.
Are you noticing one point that C is starting from some higher distance, already some What do you understand by C not starting from 0? What do you understand by that actually?
So that C was not at rest, and so it was traveling in a.
So it is
Sir,
slightly ahead of the origin from which this graph is drawn. That is the place from which their positions were recorded.
But time cannot be negative, right? So what does it mean? It means this. It means that everybody has not started from 0 point. The moment the gun is fired of run or whatever is taking place, or watch is pressed, at that very moment B was here. C had an unfair advantage. Okay, whatever, fair or unfair. And A had even. So maybe due to some reasons, A and C were given some advantage that you have to run from here, right? So when C reaches here, you should not say that distance traveled by C is this. That's wrong. When C reaches here, you should say that distance traveled by C is this. This is right, this is wrong. C was never here, so how can that be correct? If you understood what I tried to say, then what should be your answer now?
So around 6.5.
Let's see. Answer is basically this, so from here to here. Looking at the scale, it's a 0.5 scale, right? 8.5, 9, 9.5, 10, 10.5, 11, no. What type of scaling is used? 1, 2, 3, 4, 5, 6, 7 boxes equal to 12. No, 12 minus 8. 7 boxes, 1, 2, 3, 4, 5, 6, 7. 7 boxes are equal to 12 minus 8, 4 kilometers. 7 boxes equal to 4 kilometers. That's the scaling which is there in y-axis, isn't it? And how many boxes do you find from here to here? Count. 7. 5.5. Okay, 7 plus 5.5 nearly speaking.
Sir, when B crosses A, C, to get the point of C, we need to take its time coordinate. So it's not distance coordinate. It comes to 8 minus 1.75.
Now can you repeat about coordinates?
Sir, because when B crosses A, for finding how much distance C has traveled, we should take the times coordinate.
Okay. B crosses A at this time, which is here. You're right. And therefore, this point should come here. So therefore, it should be somewhere here. Now can you count how many boxes are there?
So 10 boxes.
10 boxes. Anybody else getting anything different? So assuming it is 10 boxes, it is coming out to be around 5.7. It should be all approximate sign. $5.7. Now let me know if you have any questions. How far has B traveled by the time it passes C? This is your assignment question. We stop now.